Okay, this is an investigation into the ratio of the perimeter of a regular polygon to its diagonal. Great for pi days. So, to do this, we're going to use GeoGebra, and I'm going to use the geometry screen, but I also want the spreadsheet function. So I'm going to investigate in this space with geometry, and then when I'm in this space I'll be able to use the spreadsheet functions. So we're going to think of different sides of a polygon that we might consider, the perimeter of that polygon and the length of the diagonal of that polygon, and we're going to investigate the ratio of those two values. We're going to start with four-sided shape. So we can create a regular polygon with four sides. Move the screen down. And I can introduce a diagonal. I can very quickly measure the distance. I don't need that distance of the diagonal. And if I press on the inside of the shape, I'll get the perimeter of the polygon. So I have a perimeter of 18.11, diagonal of 6.4, and in here it works like a spreadsheet function. I want to know what that is, divided by this value, and it's 2.83, which would be interesting to work out algebraically at some point in the future. Okay, thinking of a six-sided shape, I now construct a six-sided polygon. Move the screen down, construct my diagonal, measure my diagonal and the perimeter of the polygon, 20.66, 6.89, and now a ratio of 3. So I continue in this vein, constructing polygons. Sorry, I've tried to make it a bit bigger, so I wouldn't mind moving it. Can I flick it around with this one? So this is what the students are going to do, obsess about how tidy it is. It's up to you what you want to play around with there. Again, I'm constructing, I'm measuring, and I'm recording. 25.04 and 8.18. Okay, we do need to move down. Now you can get the students to go the whole way, but we might just predict for, say, 20 what we're going to get. I'll just give myself a bit more screen space, and a regular polygon with 20 sides. Obviously a bit of guesswork here with our diagonal. When the students have jumped to 100, which they will, they'll have fun finding that, but of course the error is small enough that it doesn't really matter. We get 25.3 and 8.09, and we're getting a number nice here, close to 20. So whatever students are going to do and add here, we can see what this number is getting closer and closer to. You may want to then take them to the actual circle. So if you do that, you need to construct a diameter, which takes a little bit of work. Once you've put a line through it, just construct, you first need the intersection of this and this. Now I can construct a segment between here and here, and then go and hide. Right-clicking, I can not show that object. Okay, so I can now go and measure my circumference of 18.41 and 5.86. I can then move my shape, get a new value, 27.51, 8.76. And I can see that I've still got this number. So hopefully by this point in the investigation, students recognise that the ratio of the perimeter of a shape divided by its diameter or diagonal actually is the value pi.